recording. So I gave you all a handout of kind of what we're going to go through today to try and help you kind of take notes. This is kind of something I was whipping together last minute, partly just because a lot of things changed in terms of like where I taught this and last year and how the kind of parts fit together. So you got kind of an overview of what we're going through. My plan is to kind of talk through some of the theory here, and then we'll get in and kind of do some more hands-on with that pet adoption kind of project. Okay? So our goal today, if you kind of looked at, this is going along with Lab 404. Our goal today is to start to build kind of the back end for interfaces like this, right? So this is a pretty normal search interface where you have like a search bar, you can kind of type in some keywords, some key terms that you're looking for, and a search button, as well as maybe some fields on the bottom, which are usually either text inputs or drop downs, might sometimes also be checkboxes. So you see that sort of interface pretty commonly on almost any website that you visit because, searching for data is kind of a critical part of the business. If you can't find the data you're looking for, the rest of your interface is basically null and void. Okay, so that's one thing we want to kind of implement. So things you see here, kind of drop downs. This filter for the species, golden retriever, I can one species, and that will kind of be the one that's shown. So we generally call that, in the UI world, you call that a filter. Right? If there's a drop down that changes what data is displayed or not, then that's a filter. Default, usually you would say, well, all would be the pre-selected option. So by default, it would show all species, and then you can filter down. Also commonly you see ranges. So for instance, here I've got a range that's a minimum age to a maximum age. That's oftentimes something you see, especially on like stores. You might see a minimum price to a maximum price, kind of the range of what they're willing to pay for something. Even Amazon's got that same sort of filter. Typically speaking, both of those inputs are optional. So you can either provide just a minimum age or just a maximum age. That is a hard requirement as far as the lab is concerned, just so we're clear. I'm not looking for both of those fields to be entered in. It does have to allow one or the other. Is that clear? That's one thing that's commonly missed. It's like, no, I don't have to provide both a min and a max. Usually it's just one or the other. Okay. Usually that's how users operate. The next thing you'll see is kind of a drop down of how do you want to sort the results. You want to sort it this way or that way or another way. One other way that you see that sometimes if websites are still using tables, then you might see that as like a column header on the, you might click the column header and it would toggle between ascending and descending and those kind of things. Those interfaces, honestly, with tables are really hard to implement without using some third-party plugins. I will also say that they're not really very mobile friendly. So this is usually the option that's chosen, is to just give them a drop-down because it's more mobile friendly, if that makes sense. Cool. So that's easier to do, but it also works just fine on mobile. Obviously, this interface, at least the way I've set it up, is typically the way you're going to see it on desktop. Typically, we don't put things side by side on mobile, so you might see on mobile these things would typically go via static instead of be horizontal. Okay, so just some points there as far as what the interface we're going for. So does that make sense? Another thing that's commonly in there that's not really on that mockup is we commonly have some sort of pager, right, where you say which page of results you want to see. So that might look something like this. Maybe you have 3 pages of results. So you might have 1, 2, page 3, you're on page 1. And so this is kind of pages that you're listed. And then you might also have some sort of drop down over here, which is how many items per page. So maybe you have 10 items per page. And it might actually stay like that. That would usually be towards the bottom of the page. Sometimes it's both the top and the bottom. And so you can usually pick that to say, hey, I want X number of things per page. Okay, so that's another kind of topic for today as well, is including that in there. Cool. Everybody kind of on board? Understand where we're going? So where this is going to fit in with our APIs, we've already added remember the slash list route. So for instance, you had slash API slash pet slash list, right? So this right now is listing all of the pets. What we're going to do is we're going to change that API endpoint to do the new stuff. Okay. Other thing to remember, that this is a GET request, which is also going to mean something interesting, namely that when you have a GET request, you don't ever get a body. Request body is never sent with GET requests. Is that clear? Kind of part of HTTP. So any inputs that we want to read from here do have to come from request.query instead of request.body. So all of our inputs are going to come this way. We're not going to pull any from params. We're not going to pull any from none from params and none from the body. Okay, everybody on board? So that's just one thing to keep in mind too when we get to actually building this out. If you need to take a note of that, take a note of that somewhere. Okay, so I asked you to kind of reread a few of the chapters from the building REST APIs last night, namely 15 through 19. If you kind of look through there, you're trying to looking at aggregation pipelines and cursors and find queries and things that go with that, because that's what we're working towards here. So I need to do a little bit of a refresh just to make sure that everybody's on board. I'm going to blow this up a little bit. Oh, now I want to use this. There we go. Okay. So first thing we want to kind of refresh on is, remember there's these query operators. We can use these query operators with find one, we can use them with find, and we can use them with aggregate. So we've used some of these already, but I need to remind you about some of the other ones that are out there, because mostly we've just been using EQ, and that's been fine for most of our purposes. But I do want to remind you about some of the operators that are also there, because we will need some of these for the search interface. So common queries, common field operators, query operators that you're going to see. EQ stands for equal. You've got NE for not equal, GT for greater than, GTE greater than, or equal to. You've got less than or equal to. You've also got these interesting ones, in and not in. So in and not in work with arrays. So when you see those, that would be something like, if you have an array in your, often tends to be if you have values that it could be. So for instance, if I wanted to say, let's get all of the developers and the QAs and nobody else. I can write that out as role, $sign in. Now this would be an array, and I could say, well, we want dev and QA. So this would only bring back users that have the dev or the QA role. Does that make sense? So that's kind of how we use the in operator. We say it is in this list of values. And then the opposite is the not in, NIN, says it's not in that array of options. Cool? So if you have something where you want to select multiple, you want to say it's I want to have multiple rows come back, multi-select kind of thing, that would be how you would implement it. I think for the lab, all I've asked you to do, though, is just one, right? And if you're just saying, hey, I just want this one role, it would still be an EQ. So if I just want devs, I can write it like this, right? This only comes up if you have multiple options that you want the user, that you want to allow. Does that make sense? So typical, if you're just doing a dropdown, it's just going to be one of these. If you have something that's like here's some checkboxes, right? So maybe if the interface looks more like this, and I say, you know, I want to say, hey, do you want devs? Do you want QAs? Do you want BAs? Do you want the technical managers? Right? You'd have a bunch of checkboxes, and that would be like, hey, I just want this one and that one. Right? So that's where we use the and operator, is if we have an interface like this. Does that make sense? If you just have a drop down, then you're going to use that sort of, you can just use $. Cool? So the kind of interface you have is going to have an impact on what different operator you have to use. Cool? Good? Okay, so keep that in mind. There's also ones in here where you can say that it exists, right? Does it have a field or does it not have a field? So for instance, if I want to say that it has a fixed version field, I might say, well, fixed version $sign exists, and that would only give me documents that have a fixed version field. Anything that doesn't have a fixed version field would not be included. It's worth noting anything that is fixed version is null is still included in here. You know, even if it has a value of null, it still has that field. Okay, it's just whether or not it has that field. Okay. Other thing you might commonly see, you might want to say, does it have test cases? And maybe I want to check that it's an array. So I might say something like, hey, test cases is type array. So that would only give me back ones where the document has a test cases field and that test cases field is type of array. You would discard anything else, say it's an object or it doesn't have that field. Cool? So those are good things to keep in mind. Size is also really helpful with arrays. So going back to test cases again, if I want to say that it has a certain number of test cases, I might say, hey, let's say size of 3. Right? So this says I only want ones where it has exactly 3 test cases. Okay.
Can you demonstrate how you use another operator on top of that?
Yep, I can. Because that's really helpful. Like this is the easy kind of version. Usually this is not sufficient because usually I don't want it to be exactly a certain number. Usually it's a range. So for instance, if I want to say it has 2 or more, then I could say test cases colon size. And then it is in here greater than or equal to 2. Is that right? I think I have. This one has 1 too much. Oh, no, it does, because that's a 3. No, that's not nice. So that's how the GTE would fit in, or you could do less than or equal to, etc. Right? Make sense? So I can also give it a range with that, and that's really really common, is to use the size and the comparison operators together. It's very rare that you'll see this simple example. It's usually always this one. Okay? Cool? Okay. And specifically, usually greater than or equal to 1 because you know it has 1 or more. That's kind of the most common one you see. So those are good operators to kind of keep in mind as you're working with arrays specifically exists and type and size. are often become relevant, especially if you want to filter and say, hey, I only want ones that have at least one test case, or at least one failed test case, or things of that nature. Cool. Okay. Also worth noting, there's a bunch more operators. This is by far not an exhaustive list, but those are the most used ones. Those are the most common ones. So you can read the full list going to the documentation here. It'll give you a full table of all of those. So one specific operator that I want to draw your attention to, which we haven't used up until now. There is a special operator called the text operator. Now, I don't know if you can see the outline of this field here on there, but the text operator allows us to do what's called a full text search. You generally use this with a keyword search. So like if you have an interface like this, here's a search box and a search button, right? User types something in, we want to find something that contains those words. That's where we use the text operator. Okay. Now the text operator works a little bit different. So if we're looking at, for instance, these examples, if I was going to use the text operator, typically I specify a field, right? And then the operator. The text operator is actually in place of the field. So for instance, if I want to say, erase this real quick. If I want to say all of the bugs that contain the text 404, I might say $text. Okay. It actually goes there in place of the name of the field. And then inside of there, it looks like this. Search and the string I'm looking for. So if I'm looking for 404, it would look like that. Or I put memory in there or whatever. Does that make sense? So I put kind of my keywords in here. Or I might say, I could put multiple in there in case the string would be, let's see, 404, broken. That'd be searching for both the broken keyword and the 404 keyword. Okay? So that's kind of what we're getting to. This is one of the operators we want to kind of understand. Okay? So it's worth noting that there's a few kind of interesting behaviors to how this operator works. And it's maybe not like what you're familiar with in SQL, just so we're clear. If you've tried to do some of the stuff in SQL, or you've tried to do this stuff in C# or JavaScript, it probably isn't going to behave exactly the way you expect. Just putting this out there. Okay. It actually works in a way that is generally better, but you may get search results different than what you expect it to do. Okay. So the typical way I might say to do this, if I was just working in code, I might say, hey, let's say well, the body or the text, the description of the bug, I might take the description and I might say it includes, so includes the text broken, right? And that would say, hey, it's got the word broken somewhere in the description. Okay, and so that's going to give me back a true or false. And so you can do this in JavaScript, and that's how you do this. In C# world, we call this contains. Contains tells you true or false, whether or not that string is there. Now, it's worth noting that in most language, when we're dealing with includes or contains, this just says that the characters are there somewhere, right? It's not looking at a whole word. It's just saying this sequence of characters is included anywhere in the string. Everybody clear with me there? So, for instance, a common one that you might see, let's say if I look for in, what words would that match? Well, obviously it matches the word in, but what else does what else does that match? What else contains it? sync, maybe somewhere in the middle.
So do we need to put space around it?
Saying what?
Do we need to put space around the keyword search?
Not with this one, not with where we're going. But if you use includes, right, the problem with putting space around there, then it only matches if there are spaces there. And if it doesn't match if it's like the first word or the last word, or there's a period, or things like that, right? So it actually typically isn't a solution that you can do to just say, well, it put spaces before and after it. Okay. Other words that might end in in might also be, or start with includes. So includes would also match. So you have words that it is the word, it's in the middle of the word. What could we also add in there? Can. Yeah. So all of those words would match the letters IN, right? Which, okay, seems sensical from a programmer standpoint, but from a user standpoint, this is a nightmare. That's one of the things you have to recognize. From a user standpoint, that right there is a nightmare. You don't want that action. Because I'm looking for the word in. I'm not looking for that. That doesn't make any sense, right? If you give me back all of these results, I'm going to say that your system is kind of garbage, okay? And so traditionally, the way that we've done this in SQL is if I wanted to look for the word in, so that's how I would do this in JavaScript. I could also do this in SQL, and it would look like description is like this pattern. So it's the percent meaning any characters and any number of characters, right? Regex is kind of like that star idea. Does that make sense? So like includes and like, these two things do behave the same way. Cool. So they do this behavior where they're looking for exactly just here's a combination of characters, and they're also only doing it by one field at a time. So like this is only able to look at the description, only able to look at the description. So if I wanted to combine multiple of these, I would need to say like or title is like and right on and on and on for every field that I potentially want to look at. So brand board, kind of see that's the way that we would implement this traditionally in SQL. Two problems. Again, it doesn't come up with good results. It actually is really slow. This is actually really expensive for it to do, and generally doesn't benefit from any indexes. You might benefit from an index on title or description, or in this case specifically, you have to index the combination to get any benefit. So there's that, and it doesn't give you any way to sort the results. This doesn't say, well, is this result more relevant than this other result, right? If I'm looking at these words, right, which of these words is more relevant to my query? Which one should appear higher?
It's the first and.
Okay, so this one, right? I'd definitely say that this one maybe has the highest priority. You know, this one's pretty far up there too, so maybe this gets something like a 0.8. But then these ones down here, they're not particularly relevant, so we might give them some sort of relevant score of 0.5. Now, the range isn't really defined. If I remember right, it's not bounded between 1 and 0, but you kind of get the idea. The idea with this is that we're getting, one of the things that we get out of the text operator is we get a relevant score for the results that come back. We know how relevant are they to the search terms. Okay? So that's one of the things we get out of it. It's worth noting that MySQL does have a full text index and a full text search option that was added a few years ago. The problem with it is because it doesn't have nested data, you can't index into nested things. Like, so for instance, if in MySQL, if I have an array of tags, well, that's over in another table, so my full text index doesn't work for anything that's not in that table. So that's one of the benefits of having nested data, is because all that nested data, say the test cases, get incorporated into that full text search. Okay, does that make sense? So anything that you split off into a separate collection, say we split comments, those are not going to be hits for this text operator, but things that are in like test cases, which are nested, are going to come back. Okay? All right, so everybody kind of on the board of what we're doing here. So what it actually does, the text index, this text search, what it actually does is something called stemming, okay? It doesn't do looking for this word, do these characters occur in the text? It does stemming instead, okay? So what we do with stemming is it says, what is the base word of both like the word that you searched for and the base word of the thing that is in the database, right? So it takes what's called the stem of that. And that means that some things work really, really nicely. So for instance, one thing that stemming solves really, really well is, let's say I have plurals and singulars. So I have pet and pets, right? We know those are the same word. We know the only difference there is they're plural. So their stem is just the word pet. Okay, so because they both stem down to pet, if I search for pets or pets, pet or pets, both of those results will come up, which is awesome, right? That's great. If I do this with the regular includes route, then I would have to say, okay, if I type in pet, both of them will come in, but if I type in pets, only this one would come in, right? And so that's an issue too, right? So it helps dealing with singulars and things like that. One of the gotchas, though, is you may or may not know this, English usually puts an S at the end, right? Not always, right? So sometimes you might see entity and entities, right? The plural and the singular. So this one ends with a Y, this one ends with IES, right? So depending on the word, how it's pluralized changes. But stemming does deal with that, right? So we know that with stemming, the root word is entity, so we'll take it back to that. And that's what we're basically searching. Cool? So it's actually pretty cool. This actually gets into AI type stuff if you delve deeply into it. The other thing with stemming to understand is that it's not the same for every language. So how you pluralize something changes from language to language. And so that's why, for instance, some words in English, the plural and the singular is weird because it's not originally an English word. It's like borrowed from another language, and so we borrowed their pluralization. Make sense? So when we do this full text search, it is language sensitive, right? The language of your text is going to change how it stems. Because not every language adds an S to the end or converts Y to IES. Not every language works that way, okay? So it's got to be sensitive to that, which means that if you say, I have content in, some of it's in German and some of it's in French and some of it's in English, I typically have to set it up differently depending on the language of the user and the language of the text. Cool? So it gets a little bit harder when you're dealing with internationalization. Good news for us is we're only dealing with English US as far as this project's concerned. Okay. Everybody tracking with me? Usually what that means is if I've got, say, 3 different languages I'm supporting, I'll need to create a text index for every language. So every language you want to query, for every collection, you create multiple of these. So there's usually not going to be just one index to support these queries. Cool? Questions? Okay. So that's sort of the syntax that we're going. And remember that this is in place of the name of the field. So the name of the field is colon text instead of the field that you're searching for. It's what are the things that are indexed. So when we use the text operator, there's actually a few different options that we can pass in. So search is one of them. That's the search string that you're looking for. Typically, if you just spread things out in words, it's going to say it contains 404 or it contains broken. So it'll actually give you all the results that contain any combination of those words or even just one. If I remember right, it does do some fancy stuff even. Like for instance, if you say 404 and broken, it will interpret that as actually an and. If the user types it in that way. So it does support some more natural language sort of queries. Some of those you can even try to do these things on Google because they kind of implemented the same sort of style. And I believe there's even a not in there where you can say, well, I want things that don't contain this word. So it's actually really advanced in terms of what that can be. It's more than just here's a word, here's a word, here's a word. You can also have operators in there. Okay. The next thing we can specify is what language are we specifying these things in. It's worth noting these 3 here, language, case sensitive, and diacritic sensitive. All 3 of those are optional. You don't have to send those. So language says what language are you searching, right? So for us, that would be EN US. Specifically, the way we write that is lowercase en, uppercase US. So English, 2-letter code is en underscore, and then we say US. Part of why we say that is because, well, English UK and English Australia, etc., English Canada are not exactly the same. So sometimes we have to disambiguate. Okay? So we're saying what language are you in? And you can actually do that. You can just pass the country code. You can pass, the language code. You can pass the country code plus the language code that way. But you will potentially get different results, especially when you get into things like Spanish. Spanish is a little bit more different based on the country code. So that's that there. The next option is case sensitive. This is either true or false. By default, you can see that it's false. So by default, it will go ahead and go do this in a case insensitive manner. If for whatever reason you do need it to be case sensitive, you can pass that and set it to true. But typically we do want these things to be case insensitive. The last option, the fourth option, is called diacritic sensitive, okay, which is a really weird one because English doesn't use diacritics. What is there a language that you know that maybe uses diacritics? Spanish would be one. So what would be an example of a diacritic? So like in Spanish, isn't there like an E with a mark on top? That accent mark. So if we do it as diacritic insensitive, then these 2 letters are treated as the same letter. If you're diacritic sensitive, then they're treated as separate letters, as different letters. So usually what users expect from a search is that it's insensitive to that. Most of the time that's what you want. Is you want it to be insensitive to the case and also insensitive to diacritics, right? I don't want to have to necessarily type it in with the exact right diacritics because that makes the interface more cumbersome. Even to people that are maybe Spanish native, that can be an issue. Okay? So that's what that's about. So typically we're going to leave both of those as false. Okay. So let's say I take so for instance, if I wanted to take the MFlix database that we saw, the sample MFlix database that came, and we set it up with Atlas. Remember we had like a movies collection. I might do like a text search and look for all the movies that contain Matrix, right? Or other things like that. And then I can also say, hey, I want the title and that. So that's how that works. Now, if you don't already have a text index set up, because this does require to use this operator, you do have to set up an index. If you don't have a text index already created, you're going to get this error. This is if you're using the console. Mongo server error, text index required for a text query. So if you see this come up in your application, that's what that's about. It's saying you haven't created a text index query, a text index yet for that collection. Does that make sense? So for instance, you'll need to create a text index for both users and for bugs. Everybody clear on that? That's needed to support this. Because otherwise, without an index, this is just too slow to be useful. Unlike other things where it's like, well, it might be okay to run it without an index, you can't run a full text search without having an index. So how do you create an index? So when we're working with Mongo, the easiest way to create indexes is honestly the shell. And that's how I would recommend you create all your indexes. I would recommend using shell. I would not recommend using Compass. I would really recommend against using Compass to create your indexes. So with Mongo, the way we do it, we say the collection name. So if you're adding an index to movies, I say movies, create index, okay? The first parameter to create index is what columns do you want to index? And the second parameter is the options for that index. So for instance here, I'm saying that I want to index the title, the plot, and the full plot. So I'm only indexing those three columns. And you'll notice I'm saying text, whereas usually you would say 1 over there to just say, or 1 or -1 to say index it in ascending or descending order. Instead of 1 or -1, you put text. It says a text index. Cool. In the options, as I've specified previously, I typically always want to give this a name. So here I'm naming this index full text. That way I can easily delete it or recreate it or whatever later. That makes that easy. I'm also specifying what's called the correlation here. So the correlation has to do with what language is it and is it case sensitive or not. So when I create this index, I'm going to specify the correlation as ENUS. So it's English US is the language we're going to use when we use the text operator. And the strength is 1. So strength is 1 says that this is case insensitive and diacritic insensitive. Make sense? So this is an important thing to remember to specify when you create the text indexes. You want to make sure you set that correlation. Otherwise, it's likely not going to be what you want. And remember, one of the anti-patterns is doing case-insensitive searches without a case-insensitive index. And so if you don't do that, then you don't have a case-insensitive index. Cool. Now, you can do this if you know ahead of time what all of the columns are where there's possibly going to be text. It's worth noting that this only indexes anything that's a string. If it's a date, if it's a number, if it's a Boolean, none of those things appear in the text index. It does have to be a string. It does count as well if it's an array of strings, or if it's a string nested in some other property. Those things count as well. So for instance, if I said test cases, text, that would include everything within test cases. Okay, so it does go down and say, okay, yes, I'll index all the words that are not just in that field, but beneath it. but it only considers the things that are specifically strings. Cool? That's one important thing to keep in mind. Numbers do not get indexed. And dates don't get indexed either. So when I know what all the columns are, I can do it this way. If I don't know the columns, or they might change in the future, a big trick that you can use is what's called a wildcard index. So rather than specifying all the columns that you want to index, you say $$ that says index everything in the document that's a string. That is really usually what I do. I usually don't specify out all the columns that have strings. I'm typically going to set off all my indexes this way, especially for prototyping, because this is really quick and really easy. And as I'm kind of figuring out how to build out the schema and where things go, this is the easiest thing to do before you have a picture of the whole thing. Just say, hey, we're going to index everything. It does come with a little bit of cost because obviously now you're indexing everything, even if it's something you maybe don't need to be indexed, or it might come with a privacy concerns too, because maybe it's indexing things, information that could be private. So for instance, if we're indexing this is indexing all the passwords as going into the index, okay? So, you may not want to do that from a performance aspect or from a privacy aspect, but it's going to be good enough for us to start with. So the indexes I'm asking you to create are specifically wildcard indexes. Cool? Make sense? If you do this wrong and you need to recreate it, the way that you do that, you see DB movies create index, it would be DB movies drop index. If you incorrectly created the index, you just use drop index to remove it. Okay. Questions? So hopefully you can see creating the index is pretty easy. What actually happens behind the scene is quite complicated because of all the stemming and things like that, but it's actually very easy to use, is the distinction. Okay. So does that make sense? Let me do a quick example here. If I get connected to the shell, okay, so I'm connected to sample mflix. I do need to create my index on there, but let me just show what happens without the index. So I'm going to run that query that we have here. Huh? I can. Let me just get it set up. And Evan, you were saying something about there's a quality setting somewhere now, by the way. You said, where is that?
One of the, at the bottom is when you choose that you want screen.
I don't see it.
If you click the...
You can disconnect and I'll restart it.
So the first thing you do is you click this share screen button on the bottom left corner of this one. And then it pulls up the list of things you could choose. You can also choose screens instead of applications. And you just
I always do applications.
You just choose whatever you want to choose, and then it opens up the next page. And at the bottom of that is a screen called.
Oh, it's different the first time I went through there than the second time.
It sets a smoother video by default, so you can choose better text readability as well.
Yeah. That's kind of interesting. It's not letting me. Okay. It looks like it might not work specifically if you're doing the screen share. It might be only if.
Application?
It might be if you're only doing application. It looks like they haven't fully implemented it everywhere yet. So anyway, so the point is I can do this, right? So I can do my find, text search. If I don't have a query, there's the error I'm getting, right? So we want to create that index. So I'm going to go do that now. I do believe that it came with one, the sample came with one, and if I remember it, I dropped it. So I'm going to create that example there. Error and specification. What did it complain about? That is a very odd error.
In the middle says cause combined.
Does it?
In the middle line on the right hand side, cause by index type text.
Index type text.
Does not support correlation.
Oh. Well, that might be new. They may have changed that since I last used this thing. So let me try to send that without the collation, because it sounds like maybe they've changed how that works. Okay, so there it created it. And so I should be able to do a find. Okay, and it worked. Okay, so I guess you don't have to specify the collation anymore. That's new since last year then, that you don't have to specify that. That's awesome. So there we get it. You know what I'm saying? Just give me all the ones that contain matrix anywhere in the things that are indexed, which in this case I've indexed the entire document. And I'm just saying, hey, let's bring back the title and document ID to kind of keep the results simple. So that's really good. If I wanted to say, you know, add something else in there, maybe I want a genre in there, I might be able to go back and why is that not? So I can also put in action, and I should get some more results. And you can see it takes a little bit longer to do more than one word. Well, that's interesting. Why did it only give me... There it goes. So if I type in matrix and action, then I get just not just ones that have matrix, but I also get ones that have action. So you can see it's a much larger list. The more words you add, the more results you get. Yeah. So that is a really helpful tool. Okay. So now we want to kind of walk through what we're trying to do. So text operator is going to be one of those things we use to implement the search bar. But remember, we also had some other filters and some other drop downs, some other controls we wanted to add into there. Okay, so text is enough to just get you the search box, but not everything else. So one thing we want to do is use something called an aggregation pipeline. And so aggregation pipeline is basically what you use in Mongo to run SQL queries, right? So SQL queries, remember, typically look like, I'm going to write one out here. Remember, you do like select, star, give me back all the data, when you pick some columns, select, star, from, in this case, I'm kind of doing it with pets, and I have a where clause. Or maybe I do what I was doing previously, which was movies. I'd say maybe I want just the title of the movie, select the title of the movie from movies where the title is like that percent matrix. Right, so I might have done that, order by, and then maybe order by the release date. Let's say order by release, descending, and limit it to 5%. Right. So that's kind of how we had written this stuff in SQL. Right. So what we want to do is kind of do the same thing, but do it with Mongo. Everybody on board? So we're going to do this with an aggregate pipeline. So the way an aggregate pipeline works is you start with some input data. You kind of think of this way. Start with some input data, you run it through a bunch of different processes, we call these stages, and then at the end you have output data. So you have input data coming in, output data at the end. But you're doing stuff in the middle, and that set of operations that you do in the middle is referred to as the pipeline. You can think of this one way I think about this is a conveyor belt, and you can kind of think of a conveyor belt coming through the factory. And so this is a machine that operates on the widgets that are coming through, another machine, and another machine. Whatever machines you put in there do different things, right? That's one way you can think about it. Some people think about it as water kind of flowing through and branching and things like that, but that's kind of where that terminology comes from. So you can think about it as water flow, pipelines, or you can think about it. So our goal is to kind of figure out what stages do I need to put in there and what order do they need to go in. It's worth noting that the order is important. Okay, so the order is important for a few different reasons. One reason is if you put it in the wrong order, it just won't work. If you put it in the wrong order, you won't get the right results you want because they operate in that order. The other thing that is you have to pay attention to is some of these stages add data and some of them remove it. And the more data you add to the pipeline, the slower it's going to be. The more data you remove, the faster it's going to be. So if we can work on less data, this is going to be faster. If we're working on more data, it's going to be slower. Does that make sense? So one of the things we also need to do is not just order the stages so they're correct, but order the stage so the query is faster. Okay. So those are both competing interests. Oftentimes it's I have to sacrifice something from speed to get the correctness, or maybe sacrifice something from correctness or things like that to get the speed. It's not always a straight up trade-off to do these kind of things. Straight up. So there are a bunch of different stages that are available. If you read through the reading assignment, you'll see that there's a bunch. And the list here, if you want to see all of them, there's a link. You can follow all of those. Okay, if I put that in the printout, obviously I'll send you that. So you can use the match stage, is one of the more common ones. So the match stage says, here's the criteria that I want the data to match. So I only keep data that matches that criteria, and I discard any data that doesn't match that criteria. It's basically like your find. It's actually the same stuff. What you put in match is the same as what you put in find and find one. Everybody clear with that? So it's the same as doing find. In the SQL world, this is the same as the where and the having clause. It actually functions as both. Because remember, the difference is where is in one place, happens before grouping, and happens after grouping. But they're actually both implemented with the match stage in SQL and in Mongo. So you don't have two different clauses, you just have one stage that does both of those jobs. Geoneer is very similar to the where clause. It also includes an order by effectively. So if you have location data, so for instance, if you had stores, you need to say, hey, give me the stores that are within 100 miles, Geoneer is good for that. So you can say, I want the objects that are within so many meters, as well as it will also order them from the closest thing to the furthest thing away. So it actually does both of those jobs in one stage. So that's not something we need here for the project we're building, but it oftentimes happens in there, and it's oftentimes near where you're going to use match. It's oftentimes usually pretty far early in the code. Next up is the sort stage. So the sort stage is what you use to sort the data, and that's basically your order by clause. Okay. And we've got other ones. We've got add fields, which will add additional fields to the output. Or we can do project, which can both remove and add fields to the output. Okay. So the add fields and the project stage, both of those are kind of like your select stage up here, right? So if I wanted to say, I just want the title, I would say, let's project, and I only want the title field. So the project stage, for instance, to represent that would look like $project. And I would say, okay, I just want title, so title : 1. So this is the equivalent of writing a project stage for that select type. And you can include multiple columns that same way if you want. You just keep adding them there. Okay? It's worth noting that this automatically always includes the ID. So it's a little bit more like _ID title. You can eliminate the title by saying ID 0, but typically you're going to want that ID. So just assume that you do want that ID for these exercises. Okay. Talking about matching, so matching might look like $match. If I want the ones that are maybe the pets that are an age of 10 or less, I might say age $LTE :10, close that, close that, close that. So that would be like what your match stage would look like. So this part in here should look very, very similar because we've been doing that. Okay, so that's your match stage. Your match stage includes all of those. Sort looks like this, $sort. If I want to sort something by, say, the first name and then the last name, I could do given name 1, family name 1. So that would be how I would sort something by their first name, last name. If I switch those, I did family name and the given name would be last name, first name. Cool. Are you tracking with me there? So those are the kind of the main stages that you're going to see. We saw project, we see match. order by, we saw that's our sort. If I want to do skip, so that would look like this. If I want to skip the first maybe 10 results, that would skip the first 10 results. So skip's a really, really easy stage to write. Similarly, if I just want a certain number of results, so maybe I just want to limit the results. That's how the limit stage works. So, but the limit and the skip, they really just need a number. There's no other additional data that you have to pass. Most of these you have to pass an object with the different things that you're specifying out, but skip and limit are just numbers. Cool? Okay with you? So that's kind of the syntax for these really common stages. Project and match and sort and skip and limit. Okay. Now, if I wanted to implement this same query that we got in SQL, I do have to be careful about what order I put those stages in. So in the SQL world, remember that these clauses don't run from top to bottom, right? I don't do them in the order that is listed, okay? So if I was going to implement this with Mongo, remember I need to start first with the input data, right? So where's my input data coming from? Where's my input data coming from?
The front end.
Okay. What collection? Coming from movies, right? Right? So this is actually, in the SQL world, this from clause is the first thing that happens. It might be like the second thing in the list, but it's always the first thing that happens. And we actually always write it as the first thing over in the Mongo world. So over in Mongo world, if I want to replicate that same query, I would say db, and we need to go then to movies. So db movies. I call aggregate, so that's how we start an aggregate pipeline. So instead of calling find, you call aggregate. And aggregate takes an array of stages. Okay. So I need to start with the collection that the data comes from, and then I need to put in the different stages. Okay. So again, if I want to replicate that query that's shown on the right over here, what stage do I need to put in here first? What stage do I need to put in first? Which of these clauses happens first? Is it the select clause, the where clause, the order by clause, or the limit clause? It's the which one?
Select.
Not the select one. Okay, so from I've accounted for here. The where clause, right? And so the where clause is actually basically, once I've said from and done joins, that would be the first things I do. Where is next? Okay, and so that's why where is usually going to be early in your pipeline, kind of where you want it to be. Okay, so what's our equivalent to the where clause? Looking back at that table, what stage do we need it?
Match.
The match. Okay, so if I wanted to replicate that SQL query, it would start with match. So you can see there's an array of stages. Start that with the curly brace, and then each stage is an object. Match. What's my conditions over there? Well, I'm doing like a full-text search, right? So I might say, hey, $text, curly brace, $search. And what I'm searching for was matrix. right? So that would be the equivalent. I mean, that's basically what I would put in there for the where clause. Okay. All right. So we did this one first. This was number 1. This is number 2. What has to happen next? Okay. So let's say we do the project. Okay. What columns do I want to project? What columns do I need to project?
Select ones, ID and time.
ID and type. Okay. So remember, ID is included by default. I just would need to include type. Okay. So, but if I project at this point, I've only got the type, right? I can't order by then because I don't have the released here anymore. Because if I project just title, I don't have that data anymore. So I could do a project, but I need to project title and released because otherwise I can't do sort. Okay. So the easier thing to do is just to do sort first. Does that make sense? So I would order it in doing this next. So in here, I could do that. You know, it's worth noting I could have done a project, sort, and then project. You could do it on both sides. Probably a little bit more work than you need to do. But sort, okay. So how am I sorting? Well, I'm sorting by released, right? So in here, I would say let's sort by released. And remember, 1 is ascending, -1 is descending. So this would be -1. Close that out. That's that stage. Kind of following along. So you just kind of say, I want to do this operation, and this operation, and this operation. The order you do it is matters. Okay. So now I can do project, right? Now I can go in here and I can say, let's just keep the title, because that's all I want, the title and the ID. So I would say title 1 to just keep the title. Okay. So that is our fourth stage, which just leaves the limit stage. So at that point, I would go down to, here is the fifth step, which is to go in and say, we're going to limit it to 5 results. Close the aggregation pipeline, close the call aggregate. And so that is the equivalent, note this is in the shell syntax, this is the equivalent of that SQL query. Is everybody on track? It's a little bit hard to convert between SQL and Mongo because you have to think about what order things are going to go in. But I honestly don't usually convert. I usually just start here. I just come up with it directly on Mongo side and just say, well, I want to do this, and then I want to do this, and then I want to do this, and then I want to do this. I don't usually even try to write the thing there. I really like this because it actually gives me a lot more flexibility in terms of what order things happen in. You know, it's very clear to see this happens, and then this happens, and then this happens, and it actually gives me a bunch more knobs to turn in terms of performance because I can change the order that things happen in and different things like that, versus over in the SQL world I can't. Right? It always happens in a certain order, or it actually happens in whatever order the optimizer decides to do it. Questions? Does everybody follow this? Does that make sense? So if we look at this, which of these, just judging by this, which of these stages do you think is going to end up with the most logic? Just intuitively. if we're building a search interface.
Probably the search one.
Probably the search one, namely the match.
Oh,
right. Right, so match is going to be actually where most of your logic comes in. The rest of these are pretty simple. You just kind of add them in, and they're usually actually in that order: match, sort, project, limit, and maybe skip would be in here. If I needed to add in skip, I would need to add that in before the limit. But it's usually that sort of. Okay. Let's take a break. So it's about 1:45. Let's call it a 15-minute break. We'll come back at 2 o'clock and then we'll go on to the next thing. So you're kind of seeing where these things fit together. What are you hemming and hawing about?
What's that?
What are you hemming and hawing about?
I use like a lookup with these, so that generally try to go at the top.
It really depends.
Okay.
The lookup really depends on what your needs are.
Okay.
You remember it's a join,
Right.
so if you're kind of following along with where SQL does it, SQL would do it all the way up here before the match. That's where SQL would do it. And you can do it. That's kind of the most versatile place to do it, is do it early. The problem with doing match all the way up there is that you now remember the more data you add, the slower it gets. So if you do it up there, you're already working with the entire movies collection. And so that's the slowest version of it that you can come up with. I could do lookup all the way down here and be much faster because I only have to look up 5 records.
Yeah.
I only have to do 5 instead of the entire movies collection. So lookup's a lot faster if you can get it down here, but you may not be able to do that depending on what your needs are, right? The later you can get it in the line, the better, but you don't always have that flexibility.
Yeah, I guess when we're doing some of the pipelines that are required for like the earlier lab.
Yeah.
When I was researching, I'm like, where's lookup and something?
Right.
Where's
Yeah. So yeah, I mean, usually the more general, there's a lot of cases where it's forced to be up here, and that's the more general, but it's also the slowest.
Yeah, so the lower you go.
The lower you can get it down.
Gotcha.
Yeah, if you can get it after the limit, it'll be so much faster if you can get it after the limit. But if you need that data to determine what data you're matching,
Right. Yep.
well, there's no way around it.
Gotcha.
Yeah. So that's one of the things we do is try to avoid lookup entirely.
Yeah.
So how is everybody today? Doing good? Just kind of putting some pieces together. We talked about some of this stuff already. It's just kind of doing a lot of review. Okay. Good tell. Okay, so bringing back in. So remember that our end goal is we want to end up here, right? We want to end up with a search interface. We're going to implement that. We're working towards implementing that back end with Mongo and with Node and with Express. Okay. So, we talked about the stages, right? And so the typical way we're going to plug those things together when we want to build some sort of search interface is actually usually one particular way, usually kind of one baseline set of stages. So we take in a collection. You start with the collection you want to search. We're generally going to do match first and say, hey, I want to run this where, which is kind of where this lands. I want to then sort the results. I'm going to do a skip to get to the whatever page I want to be on. So based on the page number. And then limit would be limit to page size. Right? So if I want the 5th page, and each page is 5 items long, I would skip the first 25 and then limit to 5. So this is usually how that pipeline is going to look. If we're going to build a search interface, it's always going to have those 4 stages in that order. Now, we can add and subtract stages as our pipelines get more complex, but they're typically always going to have those 4 stages in some way, shape, or form. Does that make sense? So I may be able to potentially add some more in, but that's what we're going to see. So, we start with the collection. You want to search. You mash it to filter down. You sort it to sort the search results, skip, etc. Other things that we'll interject if we need them. You might interject a lookup stage, as you were kind of asking on the break. That would be where your joins would fit in, and where the SQL fits them in is actually before the match, basically. The downside with that is it's really expensive. The lookup stage is not cheap. And remember that the more data that you have, the more expensive the pipeline is. So if I add a lookup stage up here at the beginning, it's going to be really expensive because I'm looking at the entire movies collection. Whereas if I can put it all the way at the end here, after limit, I'm only working with 5 entities. So lookup down here is very cheap. Lookup up there is very expensive. So if you can get it down further, that will help. But sometimes you can't, right? If you need it for your match, then you're not going to be able to do that. Add fields is also helpful if you need add additional calculated fields. So for instance, you may want to say, let's count the number of test cases, right? And so I might want to add a test case count and then filter down to test cases only have X number, bugs only have so many test cases or so many comments. And so you might oftentimes see an add fields before the match to add in some additional data that you can match on. And we'll typically see a project somewhere in there because we don't typically need all of the data. But where your project lands is really use case specific. Does that make sense? So usually the best place to put it is right here after the sort. It's usually where you're going to put it. But you can really put it in a lot of different places. And it's not unusual for a project to be in your pipeline more than once. Okay? It's not unusual to have multiple projects within that pipeline. Because you may need to do some mangling along the way for efficiency's sake or other things like that. You also might have more than one match. That happens too, for efficiency's sake. So for instance, you might match and then look up and then match, just so you are working with less data when you do that lookup. Count also you might want to use in there at some point to count the number of results that are coming. Right, so that would be one way you could say, let's throw a count stage in there and find out how many results there are so that I know how many pages of results there are. Okay. So those stages oftentimes get used as well, but they're not always in there and they're not always in the same place. Does that make sense? So those 4 stages you're definitely going to have, and those you're definitely going to have in the lab assignment. These I don't think you will need for the lab assignment, but they do come up often. Okay? And there's a few links in here for more information. Okay, so we, as it stands, we're having an interface. We don't know the pipeline ahead of time. Oftentimes we need to build that pipeline dynamically. And so that means that the different stages, the actual data that's in them may change, and also sometimes may change what order the pipeline is in, right? So for instance, depending on what you give me, I may need to put the pipeline in a different order. Now, simple case, let's assume that the pipeline is always what we talked about before. Match, sort, skip, and limit. It would look like this. I can say, let's create a pipeline. It's an array of those 4 stages. Okay? Now, I'm presuming in here that previously I've defined the, that should be match. So match, I'm assuming that match, sort, skip, and limit were somewhere up here in the code. Okay, come up with them dynamically. We'll talk about that in a minute. So I need to come up with those stages, and then I can plug them into a pipeline. I can connect to the database. I can call DB aggregate, pass in the pipeline. So this will return what's called an aggregate cursor. If you call find, you get a find cursor. If you call aggregate, you call aggregate cursor. So we get a cursor from that. Easiest way to use that is just say wait cursor to array, right? If I just want to say, okay, let's just wait for all of the results, let's wait for the whole search to run, put it all in an array, and I'll send the data back. That's kind of the easiest version of that. Now we'll talk about what I might want to do here instead, because these searches usually take some time. They're not usually done immediately. Plus, if you're asking for, say, 100 results, that's your limit. You might be getting back a lot of data. So we may need to do some things with that and not call to array. But that's kind of the simple version. Okay? So everybody kind of seeing that in your head? So we figure out how to find out these stages. We plug them together in a pipeline. We're going to connect to the database and do the aggregate. Now, one thing I'll mention in here, typically one of the things that we've done is, remember, we've had code that's in the database module and code that's in the route module. And we've been very careful about keeping those two separate. Because we usually want to have these things agnostic where, the way that the database is structured, the route shouldn't really know much about it. Does that make sense? Like, that's usually our requirement. The way that search interfaces work, my experience and my kind of outcome of what I've seen is that those two things are virtually impossible to divorce. When you're dealing with the search interface, the database and the route, the way you send the database back, the database and the route and the code there tends to be pretty intertwined. So this is not code that's easy to just say, hey, I'm going to move it all over the database module. So I usually don't. I usually keep all this database, all this logic for the search actually in the route itself. So this code's actually going to go into the list route, whereas usually we had done it in the database route. Does that make sense? So like the code that you're seeing here, I would actually be putting this into the route, not into the database module, just so we're clear. Everybody on board with that? It just comes up that it's not an easy thing to divorce, and so it's better to just do it that way. So next up is the question is, how do we dynamically build those stages? Okay. So for instance, with the match stage, what I would do is I would start by, let's say, well, match. Normally, you're going to start with no criteria. Normally, the criteria is, if you don't tell me any way to filter the data, I show you all of the data. So if I start with a match stage that's just empty object, that means all the data. Everybody on board with that? So we only filter it down if certain things are there, right? So we start by assuming, give me all the data. If you give me additional parameters, then we're going to narrow it down further. So I say, okay, all the data. If you give me some keywords, then I'll add to that object, I'll add a text filter. I'll say, okay, text search based on the keywords. And so I add a criteria. I add a filter to match. Does that make sense? And then if you give me another filter, let's say, hey, I only want pets that are this age or older. So if you give me a minimum age, the match.age, see this is the name of the column I'm filtering on, age is greater than or equal to name age. So I can kind of build up the filter this way. So everybody with me with the match document? So you start by usually an empty object, and then for every filter, every field that the user sends you, you're going to have an if statement that says, if you give me this, then I will do this. The implication there is every field that the user is giving, every filter should be and must be optional. Every filter must be optional. The user doesn't have to give you keywords. They might just say, I want to pick a breed and get everything that's a golden retriever. Or I just want to specify a minimum age, or I just want to specify a maximum age. And so I do that. The other beauty of kind of doing it this way, notice I only have one if statement per field, right? Other ways you can structure this, you're saying, well, okay, I've got 5 fields, I've got 25 if statements. I don't want to go that route, right? I want to go the route of one if statement per condition. So everybody on board with that? So one if statement per input that you're using to filter the data. So that kind of covers those fields, right? So if we think about this, right, this is going to go into match stage. If the keyword's there, that adds a condition to match. If they pick species, that adds a condition to match. If they pick all, we don't add anything. Minimum age, if they enter it there, we're going to say it's greater than or equal to that. We're going to say it's less than or equal to that. If that's specified, but then sort by is not a filter. This doesn't filter what data you get. It says what order the data is in. So based on this alone is how we're going to determine how to sort. So this is the only input to the sort stage typically is just this field. Okay with me there? That drop down is the only thing that concerns how we sort the data. So in terms of sorting, what I typically use is a switch because it's one of many options. So I might say, let's start with the sort. I might start with a default sort. Maybe we sort by name is the default. So I say, oh, let's start with sort is equal to name one. So by default, if nothing's picked, if the user doesn't enter anything, I'm going to sort by name. It is important that there's always a default sort. There always has to be something you're sorting the data from. If you're not sorting the data, if you just leave this as an empty object, your data comes back in a random order. You can't predict what's on page 1 and page 2 and page 3, and that's a problem, right? Because then the user goes through pages and it switches, right? It rearranges. So we can't assume any sort of default ordering. We have to specify, just so we can. Okay? So that first part's important. Specify your default sort. Switch statement, you may or may not have seen this in a while, right? We haven't really done any switch statements in JavaScript yet. But it's kind of the same syntax as basically every other language out there. So you start with saying switch. You're going to say what are you going to switch on. So specifically, we're switching on sort by, which is a string, right? Because coming from the front end. And so we have different basically modes we can sort by. So here I'm saying, okay, let's define the cases. So case name. If it's name, then I'm going to set the sort to name 1. Or if it's name descending, we're going to set the sort to name -1. Okay. Notice here that I've declared the sort as let. It has to be let because we're going to replace the stage. Does that make sense? There's not really a good way to do this as a replace. This one really does have to be. Also worth noting on there, remember all your stages need to end with break. If you forget the break on these stages, it will go ahead and go run the next stage. So if I don't have a break on this first stage, it will actually go do name descending. It'll be always sorted by the name descending rather than the name ascending. Cool? So one of the things that means is check all your sorts. Because if you missed one of these breaks, then one of your sorts is not going to work. It's going to sort it in the wrong way. Cool? So these strings can be whatever. So here I said name and name descending. Those could have been other strings. And here I'm saying, okay, let's also maybe, oftentimes I want newest data or oldest data. So I could say newest would be from the highest date down, so it would be descending, so newest would be date -1. Oldest is from the lowest, smallest date up, so that's date ascending. Okay. Are you tracking with me there? It gets, sometimes when you're working with dates, it's backwards from what you think.
What is it require like a default case?
So my default case, I could add a default case. My default case I've basically specified up here.
Okay.
So you could do either way. You could say let's not set it. I could say I could just start with sort as null and then specify that in the default. That would work too.
So they're optional.
Yeah, the default case you don't necessarily have to include. It's generally recommended that you do, but it's safe to have this be your default because in that case, then none of these cases happen. It's whatever you set up here. So that's one way to handle the default, or you can do it that way. Either is fine. Cool.
So what would wrong with default if you didn't tell us something in a specific?
It depends on what you've done otherwise in the query. So you don't want to rely on it. The way that the default ordering comes out is it's based on whatever the query optimizer chose to do. Okay, so the query, you tell it, I want to do this thing. You give it the aggregation pipeline. You say, I want to do this, this, and this, and this. But then the optimizer takes that and breaks it down into smaller operations and kind of rearranges them. So it may do them in a slightly different order with more steps than you've listed. And so based on the way that optimizes is going to change what the default ordering is. Which can mean as the query optimizer sees you keep running this query, it can actually change its mind. So it might be today that the default ordering is blah, and then in a month later that the default ordering changes because the query optimizer has run it enough that it's said, oh, well, this way is more efficient. Or your data has changed, or you've got new indexes, or things like that. So even adding indexes can change the default ordering. Does that make sense? Don't rely on it, is what that means. Is there so many different factors that can change the default ordering? Always include a sort stage. Always. Otherwise, you don't know what it's going to be. Cool? That's the thing that gets people in the biggest trouble, is assuming that the default ordering is X, Y, and Z, and that continuously is changing. So things to note, 1 means ascending, -1 means descending in there. So talking about the skip and the limit stages, okay? So a few things you want to do, typically as inputs, we're going to get 2 inputs, the page number and the page size. And actually, we recommend you always name those things that way, page number and page size, for consistency's sake. So page number is which page are you on, page size is how many elements per page, okay? One of the things we want to do is make sure that the page size starts at 1, okay, which might be a little bit counterintuitive. Typically, remember, when we're dealing with indexes, we're dealing with things, we usually, as programmers, we usually count from 0, right? We usually count from 0. And that what makes most sense to us. Like, so the first index in an array, first index in a collection is 0. And we're used to that. That's not natural to users, right? And your interface for this is user-facing, right? So your user is going to see the page. That's where the front-end person is working. So for the front end, to make the front end easier, it actually is important that the first page is page 1. So everybody with me that? Not page 0, okay? It is possible to totally implement this with page 0 as being the first one, but I would recommend page 1 as page 1, okay? Changes the math a little bit. So we're going to assume that the first page is page 1, and then page 2, page 3, etc. Okay. So when I'm pulling in the page number, I always need to have a number. Whether or not the user specifies a number, I always need to have a number, okay? And so we're going to assume if the user doesn't give me a number, the most logical thing to do is assume they want page 1. Does that make sense? If they don't tell me a number, I'm going to assume that it's page 1. So the first thing you see in here is I'm saying, let's take the page number, do this little double question mark sign, 1. So basically what I'm trying to say is if the user doesn't tell me which page, then use 1, save that back, that's now a name, that's now a page number. Now this question operator is new. It's not something we've talked about yet, but I want to kind of introduce you to it. Okay? So this double question mark is what's called the null coalescing operator. Null coalescing operator. Okay? It's short for ternary. So let's back up and talk about a ternary. Before I kind of explain how this operator works internally. It is a new operator in JavaScript. It just recently got added. So it wouldn't have been something that was in your textbook. Even I don't think we covered it in the summer textbook. And not necessarily all browsers have it, but we're dealing with the node world, so we can guarantee that we do. We don't have to worry about the browsers on checking. Okay. So here's kind of backtracking and talking about the ternary operator. So the ternary operator is shorthand basically for an if statement. The difference is that an if statement can only be used is a statement, like it has to be a full line of code, versus a ternary is a expression. So you can use an expression within another line of code. Okay, you can use it inside of something else. So a very simple thing to be do to write a ternary out, you might say if opened, I can say open question mark evaluates the string opened or closed. So if opened is true, this evaluates to opened. If it's false, it evaluates to closed. So like a really one of the most common cases that you see is you say, I've got something that's basically Boolean, and I want to turn it into one or two alternatives. Like that is the most common way you see this. Or you might see, maybe I have something that is yes, and I might say, if it's true, give me the string yes, otherwise give me the string no, right? And so it's really good for things like that, right? Or one of the things that I'd like, one of the things in the lab, right? Let's say we have I've talked to some people about this a few times already. So let's say you want to say when the bug is closed. Well, that should either be the current date or null, right? So if the bug is closed, I want that to be new date. Or null. If it's not closed, then the close date is null. Make sense? Ternaries are actually really, really simple once you get into them. Because usually the first thing is just a Boolean, and then it's just A or B. That's where they work really, really well. They work really, really well, and they're really readable when you have cases like that. In fact, this is more readable, I would argue, than a statement. Okay, everybody with me there? Okay. Any questions on ternaries? Okay. Other things to mention is that this can also be, this first part could be not just a variable, but it could also be an expression in its own right. So for instance, I could say the age is greater than or equal to greater than or equal to 3. I could say old or young. One thing to keep in mind is one thing you shouldn't do with the ternary is you shouldn't have actions. You shouldn't be doing anything in the other signs. You just want it to evaluate to a value. So I don't want to like assign any variables on these signs. That's a negative. That's a bad habit. If you need to assign variables, don't do that here. Just have it evaluate to a value. Cool? Okay. So the way the null, this nullish coalescing works is sort of a shorthand for a ternary statement. So for instance, if I say page number question mark 5, okay. What I'm saying is if it's not null or undefined, use the page number. If it's null or undefined, then use 5, right? So what the longhand way of writing this same very thing is page number equal to null or page number undefined. If it's either of those things, then it's 5. Otherwise, it's just page number. That's the long way to write that, if you need to keep that in your brain. You can see the difference in length, hopefully, right? This is a lot shorter, but that's what it's about. Now, interestingly, in there, it's not taking all the falsy values, and that's where it's different than what came before. It's not taking everything that's falsy and turning it into 5. So for instance, 0 is still 0. If I take 0, 0 and question mark 5, that still comes out as 0. Okay? It doesn't do anything as long as it's not null or undefined. That's in difference versus if you use the double bar, 0 or 5 does come out as 5 because 0 is falsy. Okay, so or works this way. Question mark is a little bit different. Okay, but that's intentional. Is everybody with me there? So I'm only saying 0 or null or undefined in this case turns into 1. Okay. Oh, I did different here because this would be, well, anyway. So page number I'm starting at 1. Well, and so it's the same idea with page size. If you don't have a page size that comes in, it's null or undefined, which means the user didn't send it to me, then we're going to use 5 instead. So it's a very quick way to just fix our variables. Does that make sense? Fix them so that, like, if you don't send a value, page 1, size 5. Okay. So now in terms of calculating what we want to skip and limit, the skip is we need to say, hey, page number -1, because remember the first page is 1. If we had started this as page number 0, then this would have just been page number, right? This would have been page number. The -1 is here because we're starting at page 1, right? So take that, multiply it by the page size. So for each page you want to skip, page in, we're going to skip that many lines. So that's how we come up with skip, and limit is just the page size. That's it. That's all you have to do for skip. And that actually never changes. Like that line of code works for anywhere you want to use it. The only thing that changes what's your default page size and what your default page number is always. So you just change this one over here. That's the only number you have to consider. Make sense? Yeah.
So page number is default to 1.
Yep.
So when it's split, just 0.
Yeah, exactly. Yeah. If you put 1 in here, we say 1 minus 1 is 0. 0 times 5 is 0. Yeah, so the first page, you're always skipping 0. That's intentional. Okay. Right? And then the next page, you'd be skipping 5 elements, and then 10 elements, and 15 elements, and 20, and 25, and they're all. Right? We're skipping a multiple of 5, but we always start with a skip of 0. Regardless of how you do the calculation, you should be starting with a skip of 0. If your first page isn't skipping 0, it's not right. Because that means you're missing some records. Okay. This formula does, at least I haven't accounted for if you put in 0, because if you put in 0 here, you'll get a skip with negative 1. That's fine. I say that throws an error, and we just leave it at that. User did something wrong. It's their fault. Okay, everybody cool with that? So we've seen how to build those different stages, right? We saw how to build the match stage. We saw how to build the sort stage. We saw how to implement skip and limit. So last thing I want to talk on this handout is how do we then deal with that cursor, right? So we could just do toArray and take all of the data, and that's like your one-line fix. It works, but it's slow. The user's going to be sitting around and waiting until your query finishes. Right, and especially when you saw, like I added matrix and action, it took a lot longer than just with one word in there, right? And so some of these queries can take some time, and you gotta be prepared for that. So in order to help with at least the perceived speed of the user, what we do is we want to stream the data back as we get it. So I get one result, I send it immediately to the user. I get second result, I send it to the user. Third result, send it back. So don't wait until it's all done to send it back. I just send back one result at a time. Does that make sense? One search result at a time. That's what I want to do. And that means that I only ever need memory for one result. I don't need memory for the whole result set. So if I want to send back 1,000 results, I only need space for one, not 1,000, which is huge. It also means just the user gets that data soon. Okay. Now, so there's a few different ways that you can do this working with cursors. There's a next method, which allows you to loop through it with a while loop. You can use the for each function, which is sort of the functional approach of doing it. Or you can use the stream, which then uses what's called a node stream, something that's built into all three of these approaches will work to stream the data. The one I'm going to show you is how to use next, because that's the easiest one. Okay, that doesn't require a bunch of extra explanation to understand how that one works. And the nice thing about this one, it comes built in. It's going to work with your error handling. So if you're using the next approach, it's just going to go to your catch if anything goes wrong, versus the for each and the stream, you have to build in your own error handling for that. It becomes a bit harder to do error handling with both for each and stream. Cool. That's one of the reasons I picked that one, is because the error handling's easiest that way. Okay. So let's talk about how we do this with next. So first thing we're going to do is we're going to get our cursor. So remember the way we got our cursor, we say db, the aggregate, pass in the Python. That gives back the cursor. You'll notice I don't need to await that, because just calling aggregate just creates the cursor. The query hasn't actually run yet, so we're not waiting for anything yet. Okay, there's no wait here yet. The wait happens later. Next thing I'm going to do is I'm going to go ahead and write the type of the response, because that's one of the headers. And you say, what type of response are we going to send back? So here I'm going to say, let's send back JSON, application/JSON. So we're going to say, this is the type of data we're sending back. I'm going to then also start writing this stuff piecemeal. If I use the JSON method, one of the problems there is that it immediately terminates the string. If you call res.json, the string's done. You can't send any more data in the response. So that's one issue there. So I'm going to use write to write it piece by piece. Okay. So I start by writing an open bracket saying that we're going to start an array, and then I'm going to start by creating this loop. Okay. So define a variable called doc, stores the current document. In that loop, I'm going to say while document await cursor.next. So cursor.next returns a promise for the next document. So I can wait for that to evaluate. And wait for it to evaluate, save it to doc. Okay, so now doc contains the next document. If we're done, that next document is going to come out as null. So I check, is it not null? If it's not null, then we have a document to work and we're going to go. Once we hit a null, we're done. That's where we get out of the loop. Okay. The parentheses here are important. You do have to put a parenthesis around this and this to make sure that this part comes first and not that not equals null part comes first. Then I'm going to say, let's write. Notice here I'm not doing, again, I'm not doing JSON. I'm writing JSON.stringify, which is actually internally what's happening when you say res.json is calling JSON.stringify. JSON.stringify takes an object and turns it into a JSON string. So remember, we're taking an object, the document, so I'm going to say the pet or the user or the bug, turn it into a string, write that out to the string. And then I'm also chaining another write to add a comma and a new line. So a comma to separate each of the objects within the array. The new line just for readability's sake. Like if I was going to read this on the other side, new line helps with that. It also encourages the string to kind of flush at that point. It says, hey, this is a place you could just go ahead and start sending data to the client. So I go through that, I use all the elements, and then finally I need to end it. So I'm going to say res.end, which is going to write the last piece and close the string. So on that last piece, remember I have to write the closing curly brace and match up with what's up there. I have another problem in the here I have an extra comma. The last one that I wrote had an extra comma at the end of it. So if I just put a brace, this would be invalid JSON because there's a comma sitting there. So I add a null. That's the last element. So that I don't have to, because otherwise I would have to figure out how to remove the last comma. I just say, well, let's pass the last element as null. That does mean on the front end, on the client, I'll have to deal with that. But this is an easy fix on the back end. And it turns out it's not too hard to deal with that and ignore that null on the front end. So that's the easy fix. So does that make sense for everybody? That's how I screen the data. So rather than writing all the JSON at once, we're writing piece by piece by piece by piece by piece. Okay? Now, in Postman, this is not necessarily going to look a lot faster, this approach versus to array. It's going to, if you were looking at Task Manager, you might see it using less memory, but in Postman it will probably look the same. Part of that is because Postman doesn't actually show you all the results until you've sent everything. Does that make sense? Postman actually waits until this before it's going to show the response at all on your screen. So while it is a bit faster, you may not see that performance difference. Does that make sense? And because your client has to be able to deal with the data as it's screened. Okay. You might notice a little bit, but it's probably not going to be very noticeable overall. Cool? Questions? So we've seen all the parts. Do all the parts make sense? Okay. Now, it might be nice to maybe put all those parts together. So let's put all those parts together. All right, I'm going to pull up our Pet Adoption version 2 project, which is where we left off. File, open folder, and I'm going to go to where I have that. There. So pet adoption version 2, because that's where we left off.
Can you change the screen?
Yes, I can absolutely change the screen. Pet adoption. Okay. Did it flip over for you? Okay. So, the good news is there's only one file we need to change. Namely, it's going to be this under the routes API. I'm going to go into pet.js. Okay. So all of the work that we're doing today is just on this one route. Just on this one list route. That's where all of this code is going to go. Is everybody clear with that? So compared to some of the other labs, in the grand scheme of things, this should go pretty quick. There's a good amount of, like, this is probably going to be one of the more complicated routes that you write, but you only have to write 2. Right? You only have to write 2 routes. That's it. Okay? So it should go pretty quick. All right. So what we need to do is we need to kind of start to rejigger the code that we've got in here right now. So the code that we got in here just says find all pets and send that data back. Well, all of that's not going to work for us anymore. Okay. So I need to start by thinking I'm going to scratch all that out between the try and the catch. And so we're just going to start with an empty statement there. Okay. So the first thing I would do is try to collect and figure out what is the data that is coming from the client. Okay. And so we know all that data. Remember I said at the beginning of this is going to come from the query, the res.query, not from res.body. Okay. So let's start by bringing that in. Well, easiest ways to bring this in is going to be to use destructure. So const brackets res.query. Okay. Because it's a GET request, I'm pulling it from the query. Okay. So what inputs are we getting? Look at the first page of your handout. Look at the UI. What inputs are we getting from the front? Okay. So we have to give those names, right? So the first text box, first one on there, what are we going to name that? Keywords. Okay. So I'm going to bring in keywords. What's the next field? A species. Okay. Next one. Okay. So min age, max age. What's next? Okay, so I'm going to call it sort by. And then other things, there's 2 things that aren't mentioned on there. I need the page number and the page size. Now, to make my code a little bit easier, I'm actually just going to make this keyword in the front a let. Let's format this a little bit. Why is that? I don't know why it's wanting to format it the way it is. Anyway, so the way it's formatting it, it's bringing it over like that. I don't know why it's choosing it. So I've got keywords, species, min age, max age, sort by, page number, and page size. Those are all my inputs. Okay. Let's do one thing. I'm going to go ahead and try to do some logging, just so we can see what's going on here. So debug, and I'm going to say debug res.query. And I'm also going to say res.send. I'm just going to send back test so that Postman doesn't hang. Okay. Okay. Let's start the server up. So new terminal, npm install. Make sure all my dependencies are up to date. And npm run start dev. Okay. So let's pull up Postman. And let's test this endpoint out as it works right now.
So we can see Postman, but I'm not gonna lie, I think it's probably better to just stick with the other way you're starting before.
Streaming the screen.
Yeah, the whole screen.
Yeah, I'm going to switch back to that. Okay. So you should see Postman now. Okay. So I'm making a new request. I'm just going to make this one from scratch. I've got one already saved, but I'm going to go ahead and just make it so everybody's at the same place. So this is a GET request, HTTP :// localhost 5000 / API pet list. Okay. So I'm just going to go ahead and hit send. And that's kind of interesting. Oh, I see what my error is. I said cannot destructure property keywords of res.query because res.query is undefined. Remember, res is the response. I want request. REQ. That's what I screwed up. So it should be req.query, not res.query. So from the request.query, I want to pull that. Okay. Back to here. Hit send again. Okay. So I get test back. Not too interesting. But what I'm interested in is what's in the log. Okay. So what's in the log is that right now, did that work? Is it really on? Oh, that's why. Yeah, that's what we should be getting. Okay. So if I send it this way, I'm getting through an empty object. So that's good. What this means is I'm not sending any data yet, right? I've not sent any query parameters. Cool? So let's send some query parameters, okay? So if I go back to here, in the URL, I'm going to say question mark, and I'm going to say foo is equal to bar. Question mark foo is equal to bar. Hit send. Okay, still test. So question mark foo is equal to bar. And what you should see back in here is now I have request query as an object with the property foo and the value bar, right? So that's what changed on this end. Does that make sense? So the way we pass these query parameters are part of the URL. And so when you're making a GET request, they have to be sent this way. They can't be sent part of the body. They have to be sent as part of the URL. Cool? There's a bunch of implications to that, and part of that means that we can, there's security implications, there's caching implications, there's performance implications to why we're doing that. But suffice to say, that's the way it needs to be. So also worth noting, so I can also add additional data, and I can say maybe fizz and fizz is equal to buzz, right? So I can also add another another value in there just using the and. Okay, hit send, look back in the data, foo bar, fizz buzz. Awesome, right? So you can see how I can send the data to the server. The first thing after the path is a question mark, and then separating all the rest is an ampersand. Does that make sense? So first one's a question mark, the rest are ampersands. And so if I want to add a third parameter, it would be that. You'll notice that as I've typed it in here, you'll notice that it's changed this params tab. It's changed the params tab. It didn't change the body tab. Right? Previously we sent everything through the body. Now we're sending it through params. This is part of why when you're sending params earlier it didn't work, because params sends it this way. Okay. So you can actually change that in here. You can either type in the parameters using this params tab, or you can do it through the URL. Both are equivalent. So for instance, if I want to pull both of those off, boop, they're not being sent. Okay. So let's look at the ones we actually want to send. So I'm going to make this keywords. And so maybe I think I have a cat in there named Watson. So I'm going to look for keywords Watson. Species is cat. What else do we want? So species cat, the minimum age is 1. The max age is 20. Sort by is, let's get the newest ones. And maybe the page number is 1. The page size is 5. So I'm kind of filling in that data that I want to see on the back end. Okay. So I filled all that in. You can see that the URL is really long now. Does everybody see that? You've probably seen this several times, honestly, surfing the web, really long URLs before. This is what's going on. Typically occurs when you're doing searching. So like if you go do a search on Amazon and then you go look at the URL, you'll see that it's a ginormous string like this. Or if you go to eBay or Newegg or anywhere else you're shopping online, that's the same kind of thing you're going to see. Everybody clear with that? So that also means that you know, if you're looking at a website and surfing around, you can kind of sneak in there, take a look, and maybe you can tweak and play around with those variables. I do that a lot of times. When the website's not working the way I want it to, I might go change those things. So that's how that fits in. So if I hit send with all of those things in place, and I go back here, now I can see all that data. Keywords Watson, species cat, mean age 1, max age 20, sort by is newest, page number is 1, page size is 5. Great, all the data went through. Good. The other thing you'll notice in there that all of these are strings. Everybody seeing that? All of those came in as strings because all of the query parameters come in as strings. So if we want it to be a different type, we will have to go and convert it to that type. Just so we're clear. Okay. And you know, if I were to log out all of these variables one by one, we should start to see that they have those values. Okay. Does that make sense with everybody? Kind of seeing how you send the data through? It's not that different from request.body. It's just a little bit different when you're entering it on Postman and the way that the data is sent. But as far as how you deal with it on the back end, handling it with request.body versus handling it with request.query is not very different. Okay, so now we want to start building things up. Okay, so what is the first stage? I'm going to put this debug up before I start writing the rest of the code. And so maybe we call this, put a little comment on here, get inputs. So we're getting all the inputs. Okay, next question. What is the first stage in our pipeline? Remember from the diagram? What's the first stage in our pipeline?
Is the match based on the keywords?
It's a match, right? Well, it's a match based on our inputs, right? Not necessarily based on keywords. We might not have a keywords input, but we do, right? But based on all the inputs, okay? So I'm going to pull together the match stage next, okay? So remember we started with match as being just a new object, just an empty object, because we start out with no conditions. We start out with saying we want all the data, okay? So if I start there, all right, let me come back. What's our second stage?
Sort.
A sort, okay. So I'm going to come up with my sort stage next. So let sort is equal to what? What would be a sensible default sort for our pets? What would be a good thing to sort them by initially?
Sort them by name?
Okay, so let's say we sort them by name. Do we sort them ascending or descending?
Probably descending.
Okay, so let's say we're going to, by default, we're going to sort them from by name as ascending to descending.
We have
What?
to make sure that name there actually matches the field name.
Right, yeah, there would have to be a field in the database named name. And so let me just check that. I can pull up my database and verify that. Looking in Compass, I'm going to connect to localhost, pet adoption, pets, and so yeah, it is name, and yeah, that's it. Now, one of the things to recognize in here, my name is not necessarily unique. So because my name is not unique, what if I have multiple pets with the same name? Well, I haven't defined how they should be sorted. So my sort isn't fully, as we might say, deterministic. Those two pets that are both named Fluffy could be in any order. I haven't specified, I haven't told it what order it should be in. So I generally need to be a little bit more specific. So if I have two pets that are named Fluffy, what field should I sort by to make it predictable? Thoughts? I've got species, name, age, gender, created date, last updated in a while. Bing, that's what I would do. I would sort by the created date. That's a good way to disambiguate which it is, right? So the oldest one or the newest one gets first. So what I would add in there is we're going to sort it by the name and then the created date. So make sure that the order is always predictable, right? I'm making the assumption that no two pets with the same name aren't created at the same time. This is a reasonable assumption, right? That they're not created at the same millisecond. That's fine. Problem solved. Okay. That's the thing that you kind of have to watch for. That's an easy gotcha to miss. To think like, well, okay, the columns I've got, that should be unique. That's done. But you have to get down to that. So that usually means adding something like the created date is usually the last column you're going to add, or some sort of timestamp in there. I could have also used the last updated for that same sense. Difference there would be every time you update it, well, that would change like they would keep changing, versus the graded data is fixed in stone, so they never reorder. Okay, so we can do that. What was our next stage in the pipeline? So that's stages 1 and 2.
Yeah, so we sorted because we didn't want to get rid of columns, and now we can bring in columns with the project.
Okay, so now we could project. All right, what columns do we want to keep for the search results? Let's go back and look at it. Okay, so going back and looking at Compass, we've got the species, we've got the ID, the species, the name, age, the gender, created date, last updated date. Okay. Well, obviously, just one thing off the bat, I definitely want to keep the ID because at some point I'm going to click on that and go to the full details of the thing. So I definitely need the ID. All right. What other things do I need to have in the search results? Okay, the name. What else? Name. Probably not. I may not. I may or may not want the created date. Depends on what I'm doing in the UI, right? For the minimum, I know, okay, well, probably what I will need, I will probably want the name, the species, the age, and the gender. That's a reasonable assumption. So I'm going to say let's pull out those fields, and anything else will be left on the chopping block. So we're going to say species 1, name 1, age 1, gender 1. So our results are only going to have those 4 columns in them. Everything else will not be displayed. What's our next stage? Okay. And what else? And skip. So I'm going to put those together because they kind of really are tightly intertwined. So skip and limit stages. Okay. So remember, things we need to do is sanitize the data a little bit. So the page number and the page size still at this point are strings, right? So I need to clean them up a little bit. Now, one thing I don't remember for sure how knowledge coalescing works with NaN. So we'll see that. So I'm going to say page number is equal to parse int. And so we're going to parse the page number. Knowledge coalesce, say 1. Page size, parse int, page size 5. Okay. Now, just for, yeah, and then I want to say const or skip. Remember what our skip is? How do I write that formula out? Multiply those two. Page number minus 1. Because remember our page number is starting at 1. So page number minus 1, and then multiply by the page size. Yeah. And limit's easy. Limit is just our page size. And so I wouldn't necessarily actually even have to create that as a separate variable. I could just do that. I'm going to try and do that for readability's sake. Okay, so what I'm going to do now so that we can see it, I'm going to change the send at the end to send all of these pieces back. So I'm going to send match, sort, project, skip, and limit. So that way, when I try to send to this, I should see how the data, how our stages are being built. So let's hit that with Postman. Go back here, uncheck all this stuff, send, nothing checked. Okay, so I do have a little bit of problem here because I'm getting a skip of null and a limit of null, which is not what I want. So I think what I'm going to have to do, because nan's not being treated right, is do an OR. There we go. Okay, so OR does handle the nan correctly. So we see that the projection comes out as that. We see the sort comes out as this, match, etc. Okay. So yeah, I had to change those to both ORs first and then OR, because I forgot about the okay. Questions? So everybody kind of up to speed with this? This makes sense so far as structure. So we start by getting all the inputs, start to lay out a structure where we're going to figure out all these stages. And so what I might want to do next is start to figure out how I can dynamically come up with these stages. Okay. So let's go back up to the match stage. Okay. So what things are going to change, what fields, what of our inputs are going to be used to determine what we match? What's the first one on the list? What's the first one on the list?
Keywords.
Keywords, right? So keywords, if you're looking again at the input, right? First thing in there is the search box. So let's do it in the order that it appears on the screen. So we're going to say if there are keywords, then I want to update the match document so that it's going to filter by the keywords. Okay. So match, I need to say match dot $text, $text is equal to, well, now it's an object, so $search keywords. Okay, that's my first filter.
We're kind of running it in Mongo language, right?
Basically, we are running in Mongo language. Does that make sense? All right, what's the next field on the form? Species, right? So I'm going to say if there's a species, then what? Done. What do I put here? So if the user specifies a species, how do I need to update the match document, the match stage? What are you thinking? Pass the ball, Michael. Be what? You said text? No, because it's not a keyword search. So what am I looking for? What field in the document am I looking for? Uh-huh. Right, and remember I want to do $EQ to avoid code injection. So I'd say $EQ species. So I say the species in the document must be equal to the species that user select. So you kind of see this path, right? Yeah. Yep. So this would be the one that was coming from the dropdown, right? And this on the left would be what was in the document, right? So say what's in the document needs to be equal to what the user selected in the dropdown. Okay. Let's just test it real quick with these two things in place. So if I go back to Postman and I hit send with nothing there, right? So if I don't send anything, match is just blank. If I send the keywords and the species, then you can see, oop, did I not save my code? Keyword species. Oh, well, this time it showed up. So there I get matched, it says text, search, Watson, species equals that. So you see it's adding more logic to the match stage. Make sense? So I can kind of dynamically build up this match stage. All right, so exercise the reader. What else do we need to add? We need to add min age and max age. Add those two. Add some filters for the min age and the max age. Because it's the field in the document, right? So remember in the database, right, the field is in age. It's like the min age is what you're entering, but you're filtering on min. That's kind of where we're going. Are you further along in the direction? Yes. Yeah, no, we're looking at pet adoption. Usually kind of small there. So we're going to fill in the min age and the max age there. And then you also recognize, well, what you need to also dynamically create is the sort, right? So the sort is going to be a switch table. So start to build those two out. I'll kind of be around, right? So add in the min age, max age, add in the sort, a switch statement for the sort file.
So we don't nest those buttons. We're trying to nest when we need max age, we don't nest them. We put separate things.
So, what do you do? You start in matching 12.
Oh. Okay, go ahead. I think there is a way to do it without nesting.
Yeah, I have to decide on how to do multiple queries.
So you just put it together. So if it's both, you say less than, and
I don't know if there's like a double name sign or just something and
just call it. That works. Okay. I was thinking of something that shouldn't be nested.
I was just like, there's a lot of.
No, okay, stone is nested, that's the easiest. Easiest way to do it. So one thing we typically want to do is we want to do duplicate, not restrict movement. Restrict movement saying one movement. If it's three, we don't do three. So you say G. And those things are not something age, or something max age, or minimum. Okay. So one combination you have to watch out for is that the test this is the set of meaning that it's actually meaning that. First stage. Not for the sort by. So not the sort. And you would have to parse the min age and max age. Right. Jump on this work, you can see this open and I think you can see. So asking again, because I asked about this earlier, and the vote was like, well, light theme was the thing that people said was easier to read. Is that still the case? Are there people that want me to switch to dark theme, or should I stay on that? Just as a right now. I'm fine with one of them. I'm the one who thinks this part of the issue sometimes. Because I can't see the light theme. Personally, I can't see the light theme
On the projector?
on the projector.
Yeah, we can only see two.
So I'm going to switch back over to dark theme.
So, IU. I think that's better on the projector. Because I know we previously, I kind of asked, and I think most people said, hey, light mode was better, but I think that.
Honestly, I think it's reversed on the projector.
You think what?
I think that's worse on the projector, but
The dark?
Where the light colored text not show up,
No.
like the comments.
Uh-huh. Ooh.
It's up to you. Everyone's working on it.
Yeah, I mean, comments are hard to see here, right? I think that's by virtue of, I think that's the virtue of the theme is not so very I think it's kind of a fight almost.
I can see better with the dark mode on the projector. When you're on Discord, it doesn't.
Yeah, and this one obviously doesn't matter. Maybe on the projector it does.
That being said, the part in the comments is obviously not the code that runs, so if you miss the comments, your code still runs. So.
It does run the same way. The feeling is just not there.
Okay.
So,
Oh, okay. So let's do this one. There. It's really directly through. Exactly. You have to switch it. Oftentimes you do that before you use this method. So function method. That way we should look like the language, right? No, you're fine. You're fine. So, what you want to do and and send down. So, what are you seeing there? What's the map on the six? So match. Say something. That's that. Start. That's how you want to do it. Run the other thing, the Zoom search like this.
Oh, I got another.
So then, first bit, one thing to recognize there, same reason we did with the date, you need more.
Oh, for these, for this, yeah, sorry, you could go to the right,
Go to right.
that's right, okay.
Or you might do maybe one on the other one, so it's exact opposite of the other one is, right? So you might say negative one here, so that that's exactly opposite of the.
Okay. Yeah, that's good that I did one of them.
One thing I remember with the main filters, things works, you can do that creative thing, and make sure that it's over the default, the main creative, same thing here. other thing that we're gonna sort the two records?
Yes.
So I can't sort it by key, because that's not a column. You sort by name, but I can't sort by species. So I can't sort by key.
Okay.
So if you've got once you get the match stage figured out, for the min age and the max age, and you've got sort by, remember what the next thing would probably be to do? It'd actually run the query, right? So if you've got those two parts done, go ahead and start adding in that aggregate call, connect to the database, run it, so you can get some results out. So we put the pipeline together. So everybody's got 10 minutes.
Can you pull your PDF so I can get my database up to yours?
Um,
I think I used it for the last time, where you're doing the testing.
So it really doesn't matter if your database is different than mine,
I know.
But I can send you the data. So in order to send you the data, what I'm going to do is I'll do the little export collection button here, export full collection. Export. Okay.
You actually don't need to. You don't need to. Just go to one data. Import file. And then the browse the file that I just put here. Okay. So then you go here. And you say two songs before. Because your data shouldn't overlap it. So you have to. Cool.
It's just like easier following along if you do an example, because I won't have to look at my data, what to type in instead.
You got the filters there, you've got that. So that will go, right? I'm going to ask you about not things. So then you can start. So, inside something. If that's not sad. So if you go back to this one. So here we're working, right? And so if you look at the return movement, so that's just on the okay. So we also remember the return movement is this number. So you got that shape, you got hook shape, so this one, so one thing is when you have a potential shape here with the edge, that's not bad. What field do you actually want to carry? In the document, what's called the edge. So you actually want to say age, not text. Now, we're telling you to do a search for age. So what operators can do? It's not search. And then you have its query operators. So which one is it? Greater. Right? So we say the age is greater than the minimum. That makes sense so far? Yeah. So you say that, and then you just kind of come up with what are the things you want to sort. If that's one thing to remember that we talked about, the name things that have the same name, so we want to disagree with that and also start with that. Or it's a name created, so it's always a group. Yeah, I do the same thing with that one, I do backwards, right, because it's kind of a so name is the same. You've got two people that age. Look. And so you want things put out the same age, so you need to kind of do some age.
Alright, so I'm going to jump in here a little bit and kind of catch up with everybody. So a few things to point out. So I'm going to add in, I think everybody's got this now. So I'm going to add in my min age filter and a max age filter. So if min, if max. So here I'm going to say, hey, we're going to match the age field. And we want to say if there's a min age, well then it has to be greater than or equal to the min age. Because I do want to include whatever the min age is. Okay. Other side of things, on the max, I'm going to say match.age is equal to less than or equal to the max age. Okay, and I think this is where a few people have stopped. There is an issue here, so I want to call everybody's attention to that. There is an issue with this code. This code does actually not work if you set both. Okay, so let's do a test. I'm going to go to Postman. And so just for testing purposes, I'm going to go uncheck these. If I just set min age, okay, it comes back with age is greater than 1. Good so far. If I just set max age, less than or equal to 20, that's fine. But if I check both of those comparisons should be there. Does that make sense? But if I check both, it just says age is less than or equal to 20. See the problem? Okay. So what's happening is when we set this, I'm saying match.age to 1, and then I'm replacing it with something else. So I'm assigning match age a value and then assigning it a different value, right? So the second one wins. Is everybody on board there? Okay. So, well, what that means is I need to have a case where I account for the fact that they might both be set. So if they're both set, I'm going to add another if in here. If min age and max age, if they're both set, well then I need both of those things in there. So I need it to be greater than or equal to the min age, comma, less than or equal to the max age. Right? So this is the case that I want it to be in if they're both set. I want it to do something different if they're both set. If both the min and the max is set, then I need to filter by both the min and the max. Everybody following with me? Okay. This still doesn't work because it goes through, okay, I do this, but then this also passes and this also passes. So I also need to set it up in a way that it doesn't do all three of those things. It just does one of them. We've got a classic trick for that. What is it?
Use
Else if. Yeah. So what I can do is I can say else if. Format, it's going to look a little bit different. So that's how I would deal with that combination. I say if they're both set, then it's this criteria. Otherwise, check if it's just min age or check if it's just max age. So there I've captured all three. It's also nice that I don't have nesting. Is everybody on board with that? That part makes sense? Pretty easy little turnaround, and now we've got that case. So things to think about. Okay. If I'm dealing with the sort by, so let's go through that now. So I'm going to say switch based on what you selected to sort by. And I didn't really specify what to sort by, so some people have come up with different things, right? So what are some of the solutions that people have come up with? What are some of the options you expected to be in that dropdown? Cody. Huh? What's your first switch? What's your first case? Species. Okay, that's a reasonable one. So maybe I want to sort by species. Case, species. Okay, so if I'm sorting by species, sort is equal to sort by the species. Okay. Does that disambiguate everything? Are there multiple things with the same species? Probably.
Yes.
Right? Probably going to be multiple tests with the same species. So what do I do next? What do I fall to next? What would be the next logical thing to sort by?
By name.
I would say name. Yeah. So the next logical thing would be to sort by name. But what if the name and the species is the same? And it's going to happen, right? So create a date. I'm sure there's more than one dog named Fido.
That's starting to look like a compound the default. You've got whatever their person's choosing the UI, and then you assign the default to different dates there.
Yeah, it usually ends up looking very similar to that. Yeah, you're right in kind of noticing. So that's usually true. Okay. I might also want to sort in the reverse order. So I might say, well, let's do by species descending, and I would just flip all those. So I'd say negative, negative, negative. Okay. So flip it, and that way it's going to be in backwards order. It's going to reverse all the search results if I make it. Okay, what's another field we could sort by? We've got the species, we've got the name, we've got what? Huh? Gender. But going down, right, think about how I did project. I had species, name, age, and gender. So I might do name next, right? That would make logical sense. So I'm going to add another pair for the name. So name is ascending and descending. And so that would just be the name and then the created date. Name and then created date. I might say then let's go to age and kind of follow that same pattern. So let's say I say age I could do that. Say if it's by age, it's by sort it first by the age and then by the created date. And maybe I do the next thing you're saying the gender, so let's do that. Now, sorting it by gender and then created date, I don't know that I would take that approach. I mean, I think this is a good place where I would want to say gender and then name. Because just going by gender and the newest is probably not going to be too helpful for the user. So it might be more helpful to the user to sort it by gender, name, and then created date. I mean, either way, you're always seeing you'll notice that all of these are always ending in created date one way or shape or form. Because I'm using it to disambiguate the order. Because my assumption is, as long as there's no two things created at the same millisecond, then just sorting by created date should be predictable. As long as that's not. If two things are created on the very same millisecond, I don't know what I can do. I might sort by ID. But at this point, it's pretty unlikely that that would happen. So I could sort by those. And so that covers the 4 fields that we're sending the user back, right? So, and that's a common thing, right? If we're projecting fields, we probably want to give the user the option to sort by those things. Last thing I want to do is generally just be able to sort by newest and oldest, in which that would be just the created date. So if I duplicate this again, so let's say we want the newest, the oldest, and so I could say sort it from newest, oldest would be created date descending, oldest to newest would be created date ascending. So these two are backwards. If you format it, it will turn this into a different format. That's okay. The one reason that I did this way is A, it took up less space on paper, and maybe it's easier to read on the projector. But if I format it, it's going to change it to look like that. And I'm okay with that. You can turn it in this way. I'm just trying to make it easier so people can see the code. Okay, so we've got those things in place, right? So we've got our stages all built up, and we could test them in Postman. We could try these different things. Maybe I go back to here, and we send all of these fields now again. And I see, okay, the match is searching for Watson equals cat, range of age is a range of 1 to 20. Sort by is created date -1. The project is that. The skip and the limit, all good, right? So that all makes sense. So I'm going to go back here and kind of add the next piece. So we've added all the stages. The next thing is to put them into a pipeline, right? So what I want to do is let's make that pipeline. Where we pull all these things together. So const pipeline is equal to an array. And because I didn't kind of use the operators previously, I do need to use the stage operators now. So at match is our match document. $match, $sort. We're going to sort it. We are going to project it. Project. I am going to add the skip. I'm going to add the limit. So that's put all these pieces together. And if for the moment I just start by sending out back the pipeline, we can just see that pipeline that we generated. So I'm going to send the pipeline back. Actually, I want to do res JSON pipeline. So res.json pipeline, Postman, send. And you kind of see that there's an array around this. Array, there's our match stage, our sort stage, project, skip is 0, limit is 0. So that's what we're going to be sending off to Mongo. Does that all make sense? So we built this thing dynamically, and if we were to play around with any of these fields, we would see the pipeline changing. So that's really helpful in terms of kind of seeing that. Okay, but I really don't want the pipeline, right? I really don't want to see the pipeline as the results. Is everybody following along now? Okay, so I don't want to see the pipeline as the results. So I need to actually run that query. Okay, so remember I need to connect to the database first. So const db is equal to await. Okay. Now I can write this two ways. I can write this as db module connect, or I could write this as just connect if I want to shorthand it. And so it might be helpful to go back up here and bring in connect. So going back up to line 6 for me, I'm going to bring in new ID and connect so I can just use the connect function directly. That's how I'm going to make that work. So bring in connect, go back down. So now I can just say connect. It knows it's coming from the database module. And we can then get our cursor by saying db.collection. And so we want the pets collection. And we're going to call aggregate. And pass in our pipeline. Okay, so we pass in the pipeline. If I want to kind of see the results real quick, I could say const results is equal to await cursor dot to array, and send back the results. So if we've got that, we should see something here. Okay. So what's our error message say? Text index required for text query.
Yeah, so let's just skip sending keywords now.
You said what?
Let's just skip sending keywords now.
Yeah, we could. That's one option. So let's leave off keywords, hit send. Okay, we've got some results. Right? And for me, it's just coming back with one. Okay. Now, what about the keywords? So send. So remember, this means I need to set up an index, right? I need to set up an index on there. So I want to open up a shell. So over here, I'm in NodeMon. I want to hit plus to create a new terminal. In that new terminal, I'm just going to type in Mongo sh and hit enter, because it's going to connect me to my local database. Show DBs. We can see that I've got a pet adoption database there. And so I want to say, let's use the pet adoption database. Use pet adoption. And we need to create an index. So db.pets.create index. Remember that takes 2 arguments. So the first one is what columns you want to index, and the second one is our options. So the first thing we need to pass is we're going to set up that wildcard index. So quotes, $***, colon, text. So I want wildcard index there, and the name of this index is full text. Hit enter on that command. Full text index created.
And so if you get that in there, you should be able to test the keyword search and it should work. Type it in again on the page. You may not have the server installed. So go to server or not. Go there. You type in services. When this pulls up. Go down to MongoDB. Usually it doesn't say that, so you want to start. Okay. Now, okay. So use the switch over. So what I would do is check all the boxes. It's so we're back here. So I have to choose these colors. I have to choose these colors. Do fix the keywords that are actually needed. So let me check the keywords and see. So try one and that's like, wow. So uncheck all the boxes. Uncheck all the boxes. So there's the others. Okay, so let's try again.
So how does this selected before?
Yeah, but we've all made it on. Do you have any other results in? So what I would try is try each of the settings one direction. Okay. So try like no. Okay. There's a problem because Tuesday is free. So there's a problem in the code. We're going to figure it out. Yep. Okay, so look at the code. So if that's the case with just Windows, so we're going to, oh, I know what it is. I missed something. So the age filter is not working because we forgot to do a little deal. So remember that min age and max age are
strings. We never fix them. Min age and max age are strings. We never fix them. So what I would do is kind of go up to the top here. Maybe do it up here. Min age is equal to parse int min age.
Now, is that gonna still keep it as undefined later on? Should we be doing this inside of our?
We do want to do it up here, or I could do it down further. If I do it up here, this is kind of the safest place to do it. So if it comes in as undefined, it's going to turn it to nan. Okay, and so any of the nans will fail these falsy checks. Okay. The problem is, like, if I do it, let's say if I were to do it in the if statement itself, then strings like ABC would pass because ABC is truthy, but then I would have nan down here. So I need to have it at least before the if statements. So I could put it down here before. That would work just as well. Right? Putting it here right above the set of if statements would work, or putting it up at the top of the file, but not inside of the if statements. Because
Technically, we could just write the if statement and it's undefined, right?
no, because I also have to check for null. And the if statement also would have to check for ABC, etc. So, long story short, I need to do the parse int before I do the if statements. Yeah, that's So what I will say, like your app, that's it. That's the whole point for this one, right? That's it. It's done. So if you've gotten everything and it's working, you're up to speed with running. You know what this is careful. If you're not 100% on this, I'll be walking around and trying to help you guys out. So if you've got all that working, all of your tested program, it's all those things are repeating as you expected. Start on line 4. Otherwise, I'll be. Right there, in the right place. There's the cost pipeline. You see the goal is 55 stages. Right. We'll also have stage in there. Unchecked lineage ones. Unchecked page. So what do you uncheck? Uncheck all of them. Check all of them. Okay, so you get some of those, right? So pick one of the ones in the species.
load up the keywords. And if you're we have subdivision. That works. Right? So that's good. So we've got it down. So uncheck the keywords and try species. Yep. So try each of the options. So, so I'm going to start from, it looks like this fragrance is probably pointing. So that's the, watch your indication. If you see something here about this, there's no sentence. Notice that I actually do this usually when it's sorting by the date. So the actual focus when you just sending a pretty date, so the first one would be full distance. So actual focus full this. This way I'm going so rather than yeah. So the missing the missing I don't using the word here the pipeline is really cool. So remember this one as a linear line. You're probably missing the viewpoint. Yep. There needs to be dot. Remember, you're not seeing it once because you have turned the key up. Be very careful about adding spaces because spaces are not in order. Don't put it in false. So go ahead and save that. Save that, and you'll see something. So we're going to verify to get to restart the server. So there it came. But notice there's a bunch of other stuff in your set express, right? Because your star said include absolutely everything. We don't really want everything. We just want the things for your application. So go back to AMD and you're going to do all the stuff. So that'll be just the things that are part of the opera. Yeah. Save that. Gotcha. Thank you. So uncheck the names. Well, your problem is that this one is sorted as right, and that one's sorted as in.
Okay, gotcha.
So go back to the database and you want to fix the data, so that those are sorted. Shall. So what you'll do is just fix that. Separate the line instead of this one. So you uncheck all the boxes. That's set. So you don't want to do this. So the early bracelets, you just want to set that. So you may not have any data. You need to have some data. You can do it there, or I would do it, I would recommend doing it. It's just looking around for great results. So pop yourself over to the chat and this one and just put things on there. Or the other option is something like that. Yeah. There it is. So we go to Postman, or sorry, Compass. That's all. So you need to get into Compass. Okay, so you're on Compass already. So what you need to do is you're going to go to add data. Import file. You're going to pick that file. So what it is, I'll check all of those. Those are your games. Suppose you have this. Wait a minute. Okay. So it's not coming back with the manual results. You want to not enter. So if you want to, yeah, this is your office question. So if you want to do a patch beginning that way. Okay, I don't know if that's the concept. So we can see that. So you want to server. Yeah, it's okay. So I would recommend doing one at a time. Or check off the time. I was always. That should be good. I think this. Yeah, this is very strengths and numbers.
Mr. Smith, do you think it's fine to start using code? No problem. Cool.
Alright.
Is that the data? Anything?
No, I'm not worried about it at that point because we can have access to this endpoint. I would already know that. They're gonna be already logged in and they're gonna have permission to see all the users. So, by the time that they have permission to use this route at all, it won't be a problem.
At my old university, you could go to a web page, which is accessible without having to find it.
Yes.
And you can type in people's names, see if they're students, registered students. Yeah. And you would get their full name. I think their phone number and email.
Yeah, that's where like if you start here, we have to do the thing that's next in the next week. We haven't done that. We haven't taken credit for this.
It is not
Things you might want to hide though, probably have to.
Yeah, of course, I'm not gonna let
There's like, you probably do want to use the project stage, hey, use the password out there.
Okay,
That's a different story. Email, fine, password, okay. Yeah, that's gonna have no reason to see it.
Yeah, you ain't that bro. You're not that guy.
You know, that dude's fall out
You're not that guy, bro. This guy can't see it.
Oh, you're sending us body. we can send all this stuff as frames. So what you can do, look at it, copy all that. Make all copy it. Those grabs, then look at it again. Okay. Yeah, so it was receiving in the 70%, trying to send this.
All right.
Get all that figured out. Okay. You said you wanted to talk to me? Or you wanted to talk to me?
See you, Mrs. Smith.
See ya. See you, Bill.